Do you remember what a tangent curve looks like? If not, that's a problem. We need to review that. It's a squiggly, Brandon, you're right. And it squiggles through the origin. That's the shape I'm shooting for here. But I made some changes to the picture. Now listen carefully. We talked about this before, but it's one of those details that's easy to forget. Before you graph either one of these problems, you have to factor this guy out of the parentheses. So step one is going to be to pull out, in this case, the 1/4. And then you're going to figure out, okay, what would I have to put here so that if I times it back together, it would give me this? What do you think needs to go there? Pi over 3, somebody said, and I think that's exactly right. Because what happens when you multiply 1/4 times pi over 3? What do you get? You get pi over 12, so we're good. That's step one. Get the equation in graphable form. Now, I'm tempted to just drop in a couple asymptotes and put in my squiggly line, but I can't because I got to pay attention to this, don't I? What does that tell me? It's moved. Which way is it moved? To the right. How far? Pi over 3. So I'm going to put pi over 3 right here. And now I'm going to drop it in asymptote and an asymptote, and I'm going to go ahead and draw in my tangent curve. Now, you are done with this picture as soon as you label those asymptotes. As soon as you figure out what the labels are here, you're done. So in order to figure that out, I need to know how far apart these asymptotes are. That's called the period. What do I know, do you remember, about the period of a tangent in general? In general, the generic, just plain standard tangent, what's its period? 2 pi. Not 2 pi. Pi. Remember, everything, there's 6 trig functions. All of them have a period of 2 pi except tan and cotan. Tan and cotan have a period of pi. Everything else is 2 pi, but tangent is pi. So a normal period or a normal tangent would have a period of pi. What does this number right here do? It divides the period. So the period of this function is pi divided by 1/4, which is 4 pi. Which means that from finger to finger is 4 pi. Now, use your common sense. See this guy right here? He's smack dab in the middle. So if the whole thing is 4 pi, then how will I figure out where this asymptote is?
Add 2 pi.
Add 2 pi. Since that's a fraction, I'll add 6/3. If I add 6/3, I would be at 7/3. How will I figure out this one?
Subtract.
Subtract 6/3, I will be at negative 5/3.
Yeah.
Now,
in the middle.
what does this 2 do?
Makes
Makes it steeper. That's very hard for us to do when we're just doing a freehand sketch and it's not even on graph paper or anything. So I'm not worried about that. In a tangent problem, I'm not worried about you reflecting that in the picture. It stretches it, makes it straighter. Now, if it happened to be negative, then you'd have to pay attention to it, right? Because if it happened to be negative, that would do what?
Make it bigger.
Turn it upside down. All right, let's come over here and do this one. All right, what's the first step? I already told you once today.
Take out the 2.
Take out the 2. It doesn't matter what the function is, you've got to take care of that. So now you're gonna figure out what you gotta put in there. What do you think? Pi over 2. Let's try that. It's a good guess. Does it work? Remember, if you multiply these together, you're supposed to get that. Is that what happens?
Yeah.
Did you want? I don't think that gives you pi over 4. What happens if you multiply 2 times pi over 2? You get pi. So that's not the right number. Oh, pi over 8. What do you think about that?
Yeah.
That works, doesn't it? Now, what does that tell me about my picture? Yeah, whatever used to happen at the origin now happens at negative pi over 8. Well, how do I graph a cosecant? What does that look like? Well, it's the reciprocal of the sine. So I start by actually graphing a sine curve. Just pretend for a minute that it's a sine curve. Graph this. Now that should be easy for you. Remember, a sine curve looks like this. That's a sine curve. Right? So, is that negative do? Turns it upside down. So I have a sine curve that's going to be upside down. And the hills go up and down 3. So far, so good? Now, what's the period of a sine curve supposed to be?
2 pi.
2 pi. But this one has been divided by 2. So this period is just pi. Now, what does that mean? That means, Guzman, you paying attention? No, you're not. What's this? This. Yeah. I do. Is it supposed to be there? I would say definitely not. Right? So you're going up on the board. And by tomorrow, if it's still there, Mr. Guzman. Okay. All right. Now, from here to here is pi. That does not mean that this is pi. The distance between my fingers is pi. So how am I going to figure out what that end label is?
Add pi.
Add pi. Well, this is a fraction, so instead of adding 1, I'll add 8/8, which will put me at 7/8. Groupies, if you start at negative 1/8 and you travel 1, you're going to end at 7/8, right? All right, what's halfway in between? Now, let's not make this harder than it is. Midpoint is average. Okay? What's negative 1 plus 7? Divided by 2. 3. So this is 3/8. This is the midpoint. What's negative 1 plus 3? 2. Divided by 2? So this is 1/8. 3 plus 7 is 10 divided by 2 is 5/8. That is a magnificent picture, but there's one thing wrong with it.
You have to flip it upside
I have to make it a cosecant. Remember, this is what we're actually supposed to be graphing. But we never do that first. we graph our sine first. Now, do you remember how to get from the sine to the cosecant? But before I flip it, I have to do something else. I have to drop in some asymptotes. And where do the asymptotes go? The asymptotes go wherever we cross the x-axis. So wherever the sine is 0. Here, here, here. Then we flip it. So see this guy right here? He gets flipped down. And this one gets flipped up. So the red is the actual answer to the question. The red thing is the answer to the question. Okay, starting to come back a little bit. Okay, let's see. Let's do a, about a cotangent. All right, here we go. We're going to graph this cotangent. Step 1. Take out the 1/3. Steinmetz, you paying attention? Kate? She's probably more fun than I am, but right now you gotta be paying attention to me. Okay, what do I do? What do I have if I take that 1/3 out? We'll make something up and try it.
It'd be 3 pi over 10.
Would it be 3 pi over 10? What happens when you multiply 1/3 times 3 pi over 10? Don't you get pi over 10? Yep, it would be 3 pi over 10. That's exactly what it is. Never enough time. All right, you got an assignment posted online? Of course. Have a great day. Think about how we want to arrange these desks.
Is there also an assignment that we had over break?
Yeah.